is the Kinanthropometry report, which is the output that you get from the full Isaac profile, also known as skin folds. Now, there are a number of different body composition methods available, which I explain in a different article. Body composition analysis can be very useful for determining the effectiveness of a diet and or a diet plan, and these measures can be taken baseline throughout and post any kind of intervention, or just throughout anyone's sort of general year, just to see how they're getting on. Now, the Isaac profile can be conducted basically anywhere because all the equipment is mobile. It requires a trained practitioner to do so, and that is one of the limitations of this particular method, is that the effectiveness increases dramatically or significantly if the same practitioner repeats the measures, which is what I always try to do as a practitioner. So it requires a number of different measurements to be taken. As you can see on the left hand side, you've got basic, lengths, breadths, girths and skin folds. Now the basics require stadiometers, so measuring height, also require scales to measure body mass. The lengths and breadths require special calipers to measure those. Girths require a special tape measure, and skin folds are measured using Harpenden skin fold calipers. And what we get from these data, which take approximately 20 to 30 minutes to measure, depending on the efficiency of both the participant and the practitioner, are these results here. So on the top left, you've got a pie chart that shows the breakdown of each of these 5 compartments and displayed as a percentage. So what you get from this analysis, starting with the top left-hand corner, is a pie chart showing the breakdown of each of the body compartments as a percentage. To the right of that, you have what's called a forest plot, which shows where this individual sits for each of those compartments compared to their particular cohort. So in this case, this is based on age, gender, and sporting type. Now below that, you have the table that displays each of the body compartments as both a percentage and an absolute value. So you have adipose mass, also known as fat mass, muscle mass, residual mass, which is everything else, so heart, lungs, etc. You have bone mass, which is your skeleton, and skin mass, which is self-explanatory. Now, as I said, you've got the percentage, but you also get the absolute mass. Now, absolute mass is something I would prefer people to concentrate on. And one of the reasons for that is, say, for example, someone is trying to reduce their fat mass percentage or adipose mass percentage. They could simply increase their muscle mass, and that adipose mass would go down as a percentage, even though the number might be exactly the same. So I often ask people to think about the absolute value rather than the percentage. What you also get from this kind of analysis is an ideal weight, which again is based on the cohort which you've been compared against. The overweight adjustment, which shows how much that person is above the average for, again, that cohort. And again, extra muscle mass, how much muscle mass they have above that. Now, obviously, if their muscle mass is below the average, this will be presented as a minus figure. Again, these are fairly useful bits of information, but again, it is comparing to a cohort rather than looking at the individual, and their needs and requirements may be different. This is where basal metabolic rate comes in. This is the result of the Harris and Benedict equation. So you can see that this individual's basal metabolic rate is 1,783 kilocalories per day. So what this essentially means that if the person was to lie down and do nothing, this is the amount of calories that would be required to maintain their current weight and all their physiological processes. This particular person had a high level of activity, so their total energy expenditure is based off their level of activity and their basal metabolic rate. In the table below that, you have the sum of skin folds. Now, these are particularly useful for a number of reasons. One is that, similar to mass, they are absolute figures. They're not open to interpretation depending on which type of equation is used. And secondly, particularly if you're an elite athlete or aspiring elite athlete, a lot of institutions publish their data on these skin folds for particular sports. So if you're an up-and-coming or aspiring swimmer, you could actually compare yourself to where the elite swimmers fit. Say, for example, the Australian Institute of Sport will have published a number of research articles reporting that. So it's good for comparison, but again, we need to take into account the individual and their individual needs. In the second to bottom box, you have the muscle bone index, which I find a very useful measure, and one that you get from Kinanthropometry and not from the other methods of body composition analysis. And what this presents here is the amount of muscle to bone ratio. Now, this is naturally capped at 5:1. So what you can use this information for in particular sports is how much more muscle mass an individual can put on. Now, if someone is looking to gain weight but is at 5:1 ratio, we know that their muscle mass cannot increase, that any increase in mass would have to come from an increase in fat mass alone. And that comes down to the individual and the coach of how to manage that. Then in the bottom box, you have body mass index, or BMI. Now, BMI is one of these measures which is very useful in the general population. It is comparing height and mass, or height to weight. And it shows where someone fits, whether they're under, over, or at a healthy weight for a general population. However, when it comes to athletes, we often find that this is inaccurate, because it doesn't take into account usually people who do a lot of training and have higher muscle mass than the average population. So it is a useful tool for general population, but maybe not so advantageous for an individual. Below that, we have somatotype. So there are three types of somatotype. You have mesomorph, so this is a typical bodybuilder build. You have ectomorph. Ectomorphs tend to be taller, thinner, and have dome-shaped craniums. And then you have endomorph, who tend to be shorter and have more fat mass than the other two. Now, no one person is any one of these. We're a combination of them, and they can be adjusted depending on training and diet. And this is reported here in a graph, but also at the bottom there as a numerical value. And then in this page, it explains what each of those means, depending on whether you're looking at mesomorph, ectomorph, or endomorph. So in summary, it's a very useful method of ascertaining body composition. It's mobile. If you have a trained practitioner, it can be done basically anywhere. It's somewhat invasive in the way that the person would have to be in shorts and t-shirt or shorts and vest, but apart from that, it's pretty straightforward.